that you have to be aware of. Scale and size, okay? There's scale versus size. You're going to get two different numbers that go with this. Let's say you want to make a box, okay? So we've got a box. We've got a box around here. Here, let's. Wish I had a tape measure on me. But if we took this speaker, for example, we're going to call this speaker. What would you guess that is? Let's say it's 40 inches high, and it happens to fit a piece of paper really well. So we're going to say this is 40 inches tall. We're going to say it's 9 inches wide, and we're going to say it's 12 inches deep. Okay? So we have the full scale thing, looks like this. We were making this and we knew that this was from here to here. We called it 9. From here to here. We said it's 40. And here to here. We'll call that 12. Okay, I'm going to change a number here and make this 8 because I want to make this easier on us. Okay, now, if we were going to take this and we wanted to make a model of it, we could say, and these are all inches, so we could take this and make a model of it and say, I want to make this using half scale. I want to make a half scale model sort of thing, or a 1/2 inch to the 1/2 inch to the inch. Okay, that would be like 1/2 to 1. So in this case, we would make it, instead of the full scale, which is 8 by 12 by 40. Okay, that's a 1:1. If we make it 1/2 to 1, then we're going to take this and we're going to take 8 times 1/2, which equals 4. We're going to take 12 times 1/2, which equals 6. We're going to take 40 times 1/2, and that equals 20, and our model would end up being 4 by 6 by 20. Okay? If we were going to make it 1/4 to 1, then we would take 8 times what? 1/4, and what would it be? 2. We take 12 times 1/4. What would it be?
3.
We take 40 times 1/4. What would it be?
10.
Okay, and our model would end up being 2 by 3 by 10. Okay, so that's how you're going to scale things down that way based on how much you're going to use for this. Now, when you do this, you end up with something where there's a difference between scale and size. If I want to make something that is 1/4 the size of the real thing, I can't do any of these numbers that I just showed you. Okay, let me show you why. Let's take this cube.
Mr. Jones, it might help if they're scaling down literally like the planets of the solar system. is their major challenge right now. So this is probably right up what they really need to understand.
Okay, now that I know what you're doing, that's not my best drawing of a box ever, but if I did this in 1/2 scale, this is one whole thing, and I did 1/2. I'm going to cut this side in half. I'm going to cut this side in half. I would cut this in half, and I would cut this in half. And the same thing up here. Now, how big does that make one of these? If I cut each thing in half, now the only thing I've got is this area right here. Well, that doesn't work, so we'll just do hash marks.
The red pen doesn't work?
No, it's fine.
I got another one over here.
So it only takes up that little corner. So that little corner of it, is that half of that? It's done to, it's a 1/2 scale, 1/2 to 1, and so we took half of it, but it only takes up 1/4 of the side, doesn't it? Because 1/2 times 1/2 equals 1/4. Remember, when you're working with fractions and you're multiplying them, numerator times numerator, denominator times denominator. So if you're doing a 2-dimensional shape and you do 1/2 scale, it's 1/4 size. Okay, so in 2 dimensions, okay, 1/2 scale equals 1/4 size. Does that make sense? We have 1, 2, 3, and then the shaded area is 4, isn't it? So we divided both sides in half. We have 4 areas there when we divide it in half. So one of those areas in 2 dimensions is only 1/4 the size. Now, if I blew this box up into lots of little drawings, I would end up with this now. This isn't the greatest drawing in the world, but I think you'll get the idea. If I took this and took it apart now, we'd have 8 little boxes, wouldn't we? Because you got 4 up here and 4 on the bottom. So in 3 dimensions, you get 1/2 times 1/2 times 1/2. What's that going to equal if we multiply those together? 1/8. So if you take 1/2 scale, in 2 dimensions it's 1/4 of the size. But in 3 dimensions, it's 1/8 of the size. So you come way, way down. Now, any of you ever work with models or model railroads or anything like that? You look at those things and they give you these numbers like 1 to 32, you know, 1 to 32 size. They're giving you the size. You would have to take whatever they say the size is and find the cube root of that number to get the scale that it is done to, sort of thing. If something says it's 1 to 64 size, then it's done to 1/4, because if we took 1/4 times 1/4 times 1/4, 4 times 4 is 16, 16 times 4 is 1/64. If we did that up here, we would have 1/4 times 1/4 equals 1/16. Okay, so 1/16 in 2 dimensions is 1/64 in 3 dimensions. So if you know what scale you want to make something to, you have to take the cube root of your denominator. Everybody, does anybody know what anybody not know what I mean when I say cube root? Okay, how many of you know what a square root is? Okay, good. Square root, a number times itself is a square, right? So if I take 4 times 4, that's 16. 5 times 5 is 25. If I want to know the square root of 25, what times itself equals 25? That would be 5. What's the square root of 9? 3. What's the square root of 4? 2. Okay, cube root, same thing. It's what times what times what equals, if they're all the same. So the cube root of 64 is 4. 4 times 4 times 4. If you wanted to know what's the cube of 5, 5 times 5 is 25, times 5 is 125. So the cube root of 125 would be 5. 27. What's the cube root of 27? 3. Okay, so you guys understand cube root. That's what you would have to find to get to the size, figure out the size. The scale is that number that is the cube root. You're making it to 1/2 scale, then all your numbers are going to be based on that. So you guys are going to do a model of the solar system. You probably can't do something where you said, let's use 1/2 scale. I mean, what's the moon? 227,000 miles away or something? So, okay, we're going to make this 1/2 scale, and it's only going to be 113,500. That ain't going to work. If you tried to do 1 to 227,000, that's not going to work because you still need a mile. So you're going to have to find a number that you can actually work with. Now, what I would say you did is space and stars beyond the moon, because we went there when I was a kid. I don't pay that much attention to where all the planets are, but if you're doing all the planets, how far away is Pluto? Anybody got that? Some million, billion, something miles. You're gonna have to take that number and figure out what scale you can use to represent that. How big a space do you have for your model? I'm going to guess that you're not going to make something that's any bigger than half of one of these tables. So you're going to have to figure out a number where you said, let's say 1 inch equals 5 million miles. So if 1 inch equaled 5 million miles, to get to that distance to the moon, let's just use easy math to say it's 250,000 miles to the moon, you're going to have to say somewhere around an 1/8 or a 1/16 of an inch would be the moon in each of your planets. So what you might have to do is this. When we can't fit something in, we do this. We draw, let's say I want to draw a piece here, and I want to say this is 100 feet long. So say I'm drawing a board here, and it's supposed to be 100 feet. I do this. It shows 100 feet that way, but it shows that there's a break in here. I couldn't represent 100 feet on this board. I couldn't represent 100 feet in this room. So I draw it, I put 100 feet there, and I put a little break. So if you guys are setting your planets in something, you might have to set a small break like that. Are you making a model of this? Yeah, the digital, I'm not so worried about. You're gonna have to try to really, and scaling the planets, I think you can scale the size of those pretty easily. You're gonna work with your diameters to do that, okay? So by working with your diameters, you're taking the one straight dimension that you've got that you can create. So work with your diameters on that and scale your planets, and then your distances that they are apart, you're gonna have to cut a section out to be able to show it and show the distances in order to do that. Does that make sense? Anybody have any question about scale and size? It's not a whole hour lesson, unfortunately, to take up any more time with you guys, and I have to be somewhere in the other side of town in a few minutes. So if you don't have any other questions, that's what I can give you to help you. Anybody, no questions? Everybody understand how the relationship and how they work? Okay, scale your planets based on the diameter, and that's going to be the easiest way to, figure out how big each of them should be in relation to one another. All right? You guys have a good day. Be cool for Mr. Mays, and I'll be back. I'm actually not here the next couple of days, so tomorrow I'll be here I'll be here towards the end of your class. So if you come up with questions, if I come in, catch me, and I'll answer them. I'm usually in the office here. Okay?
Thank you.
Thank you for being attentive.